Welcome. We are delighted to have you join us for this special webinar on holy heat pumps. I'm Brooks Barrett, the Environmental Justice Minister for the United Church of Christ. I'm joined by my co-host, Tiffany Hartung of Interfaith Power and Light. This webinar has truly been the fruit of a collaborative effort. Tiffany and I are part of a multi-faith group that has been meeting regularly to figure out how to bring the best possible resources and knowledge to communities of faith and making the most of the new government programs and incentives available for energy efficiency as well as solar. Lots of gratitude to our co-sponsors for today. They include Adama, Blessed Tomorrow, the Christian Church Disciples of Christ Green Chalice Program, Third Act, the Unitarian Universalist Association, and United Women in Faith. Tiffany, I am so glad to be hosting this event with you. Before I introduce our four panelists for today, can you set the stage by telling us what makes heat pumps so holy and why are they a hot topic for today?
Thanks, Brooks. I'm excited to join you today with this, and I'm excited to see all the folks joining from across the country and across the Interfaith Power and Light Network. Heat pumps are a very popular topic, and I'll just share sort of, as people of faith and conscience, we're called to care for our sacred earth and to work to heal the climate. One way to do this is to reduce the emissions from our houses of worship, our congregational facilities. Many congregations have set a goal for themselves to get to zero emissions by 2030 by changing their operations to go all electric and getting their electricity from renewable sources. For many congregations, that looks like replacing old furnaces and air conditioners with new energy efficient heat pumps that provide heating and cooling of air and water, plus changing to solar to charge the system. The Inflation Reduction Act, which many of you helped to pass last year, provides the greatest climate investments in the U.S. history. These federal incentives in the Act are also available to nonprofit organizations such as congregations for the first time. This exciting new development qualifies congregations for federal payments for energy improvements, such as heat pumps that we'll talk about here today. So with this new funding and the recent advancements in heat pump technology, this is really a great time to start cutting fossil fuels at your facilities. Interfaith Power and Light is pleased to partner with United Church of Christ to host this webinar today and our other partners. This recording will be posted to IPL's federal funding resources webpage and our YouTube page and sent to all registrants afterwards. I'll drop that link in the chat here in a moment. So if you're wanting to share this, it will be thoroughly documented. And today we'll learn about what heat pumps are, the different kinds of heat pumps, the best applications for each, and then we'll touch on the federal financing that's available. And finally, we'll hear from a congregation that is zero emissions with two kinds of heat pumps powered by solar and on their property. So I'll turn it back over to you, Brooks, to get us going.
Thank you, Tiffany, for setting the stage for us. Let me introduce our guest panelists for today. We have with us Colby May, who is the president of Energy for Purpose. Colby is a certified energy manager, having specialized in energy efficiency for the past 15 years. He has performed energy audits at over 2,000 commercial-sized facilities across the nation, including churches, seminaries, local governments, universities, K-12 schools, and more. Colby will be joined by Jim Brown, who is the engineer at Energy for Purpose. As a professional engineer, Jim has specialized in the field of energy efficiency for the past 40 years. He has conducted energy analyses and designs of energy efficient installations for over 600 facilities in the United States and abroad. John Agan is the policy analyst at the U.S. Department of Energy. He has worked in various policy-related roles and capacities at the Department of Energy for 9 years. He is especially well-versed in the area of energy efficiency. And then finally, we have with us Jim Fritz. He is a retired music educator and a longtime member of Good Shepherd Lutheran in Decorah, Iowa. Jim has been a dynamic force for energy efficiency at his church and is known for giving tours of their facilities. We're delighted to have each of you with us for today. Colby, we'll let you start us off.
All right. Well, thank you very much, and sorry for the informality of obviously we've been doing energy audits at the Dakota Reservation in the North South Dakota with churches in that area. So we're kind of working with the time that we have. So we're really grateful for the time we have. But I'm as you said, I'm a certified energy manager. I'm also an ordained pastor. Went to Gordon Conwell Theological Seminary. Wrote my thesis in Congo during the Kivu conflict, and just really became passionate about houses of worship, environmental stewardship, and just really the call and the mission of the church. Is there where I really fell in love with the way the church uses the environment for the mission of Christ. One of our missions is cross-cultural missions, but just how the church uses creation as its, as part of its mission. So just a couple quick facts, and I want to turn it over to Jim. A couple quick facts. According to State of the Plate, we tithe nearly $50 billion to over 400,000 houses of worship in the U.S. Of that $50 billion, behind salaries, our second largest budget item is utilities and facilities. So $10 billion, we, as a house of worship, we spend in the U.S. nearly $10 billion on energy. But according to EPA, or the Environmental Protection Agency, 30% of the energy we use is wasted. Now, I know that's easy for me to say, but as facility managers or pastors or lay people wearing that hat of facility management, we wear 10 different hats. So it's hard to be proactive because we're mostly reactive. But that also says that 30% of the energy that we use can be recaptured at no or low cost. So obviously our focus is energy audits. Most houses of worship, 40 to 60% of their energy use is HVAC related. And today we're talking about heat pumps. Obviously, we do focus quite a bit and recommend the churches move over to electrification. So to do away with fossil fuels. Economically, we're almost there. Obviously, many grids are still powered by fossil fuels, but Jim will kind of talk about that a bit more. But again, just wanted to kind of set the scene. If 40 to 60% of our energy use is on our HVAC, heating, ventilation, and air conditioning, that means most of our focus, in my strong opinion, and our strong opinion, should be focused on how we manage and what we install in that. So Jim, I'll go ahead and hand it over to you.
Great. Good afternoon, everyone. My name is Jim Brown, and I've been given about 10 minutes to talk about a subject that I'm really passionate about, so I'm going to have to talk very quickly. Heat pumps have been around the engineering world for quite some time. 25 years ago, somebody invented something called a reversing valve, and all of a sudden, bingo, we moved energy efficiency and sustainability into the HVAC industry. So we're almost there. I want to explain why I'm saying almost there in just a few minutes, but we are almost on the path toward becoming far more sustainable in this country. We just have to direct a focus toward things like heat pumps. Let me have the next slide, please. Heat pumps are based upon a thermodynamic law. I'm sure you guys read your thermodynamic book last night before you went to sleep. There is a law that says heat flows from a warmer source to a cooling sink. And because of the drastic characteristics difference between our environment and the refrigerant that's used in an air conditioning system, we can still heat when temperatures drop down to 25, 30 degrees outside. The way the system works is what you see on the slide here is the cooling cycle. The refrigerant is compressed to a very high pressure, high temperature gas that goes through the condenser coil, and through that condenser coil, a lot of the heat is thrown out, and it becomes a warm liquid that goes through an expansion valve. And like any other gas, when it expands quickly, this turns into a very cool temperature liquid. That liquid goes through the coil that's inside your house. And a fan blows air across it, and the cooling goes into the comfort area. Now, the beauty of heat pumps is that we no longer have to have those natural gas or oil burning or coal burning devices within our home. We simply turn on the reversing valve, and the process is changed, where the hot high pressure gas from the compressor goes through the evaporator, and that heat is then pushed back into the room for comfort. That's how the system works. Let's try the next slide. Okay. But the question that we have today that we need to not forget about is that we're not really all the way to sustainable yet. We're getting close. Sustainable energy is energy that meets the needs of our present needs without compromising the needs of our future. We're not without stealing or the fuel or harming the environment for our children. So are heat pumps sustainable? The answer is absolutely yes. Heat pumps are sustainable if you're using, the whole system is sustainable if you're using a source of electricity such as solar, hydro, or wind generated power. Okay. However, on the other side, most of our electricity in America is still generated by carbon-based fuels. And if the electricity is coming to us from a carbon-based fuel, then we're not quite to the full sustainability yet. We'll talk a little bit more about that in just a second. The other question is it geothermal? Well, geothermal simply means heat from the earth, right? So are heat pumps geothermal? Well, in the heating cycle, yeah, they are. They are geothermal, where we're drawing heat out of the water or the ground or the air and bringing that heat into the room. In the cooling cycle, no, not technically. It's not geothermal because the ground has become our heat sink. We're drawing air out of the room, and so it's not going geo. Heat is being deposited in the earth rather than being drawn from the earth. I ran over that real quickly. I hope you understand, but it's key for us to know going forward that we still have some way to go here before we can call ourselves fully sustainable. Okay, next slide, please. Okay, it's the same old story, guys. Our electric goods suppliers over the years have not kept up with consumer demand for sustainability. We still have most of our electricity generated and produced and generated using carbon-based fuels. Okay, the problem is electric heat is 100% efficient. That electric resistance coil in your house is 100% efficient. But the problem is to getting that coal or oil or natural gas out of the ground, running it through boilers to create steam to turn generators, and then distributing that electricity to our households. We lose about 70% of the energy in that cubic foot of natural gas. Okay, so the electric companies really only have 30% of their product that they can sell. So as a result, we're energy efficient using electricity, but the cost is higher. All over the country, you will find that the cost of a BTU is somewhere between 3 to 5 times higher for an electric BTU than it is for a natural gas BTU. So what we're trying to do is get the concept across that site-generated electricity is the way to go, especially for large HVAC plants. If you have a huge church or a huge commercial facility and we could put in a solar panel system that would allow us to produce the electricity that's necessary, then we eliminate that 70% loss and we have become most efficient from an energy standpoint and from a cost standpoint. Let's go to the next slide. Okay. All right. Since we only had a few minutes, and I've just got a couple of minutes left, actually, one of the things we were asked to do is to help people who haven't seen or operated heat pumps, just give you a few clues on how they operate. Well, heat pumps are going to run continuously when the temperatures outside drop below 25 to 35 degrees. You don't need to be alarmed. They are supposed to operate continuously. Just go to your thermostat and check to make sure the auxiliary heat icon is on, because all the heat you're going to get out of that compressor system outside it will produce comfort in the building down to around 25. Then you're going to need the auxiliary heat. Okay. Now, heat pumps do accumulate frost on the outside coil. Don't let that bother you either. There are automatic defrost cycles on the system. We have a lot of people around the country who get real concerned when they walk outside and they see coil on their condensing unit they see ice on their condensing unit's coil. You will hear a hissing sound periodically. Well, that's just the system heating up the ice and creating steam. Okay, don't panic. It's going to last 5 or 10 minutes. Don't go turning off the system. Okay, the thermostat on your heat pump has an emergency heat option. But no matter how cold it gets outside, do not turn your thermostat to emergency heat only, because that's only there to allow you to operate, to have some kind of heat when the condenser outside the outdoor unit is not working anymore. Those emergency heaters are not sized to give perfect comfort within the building all by themselves. So make sure you do have an emergency heat in your system, but make sure your thermostat is not set to emergency heat. Put it on auto, okay? And then the last thing I have to say is that because heat pumps run year-round, it is extremely important that you keep the maintenance up. Keep the filters clean, keep the coils clean, keep the weeds away from that condensing unit outside to make sure that it's operating efficiency. Okay, that was my last slide. So I hope everyone was able to understand how the system works. It's very ingenious. But the heat pump, it is not a new concept. The concept has been around for a long time. We simply need to figure out how to make the overall system sustainable and get away from carbon-based fuel, like natural gas furnaces in your home. Okay?
Thank you, Jim, and thank you, Colby. We appreciate you getting us started with that wonderful introduction to heat pumps. We'll now turn it over to John.
Thank you very much. It's great to be with you all today, and thanks to the team for helping get the slides up. Really appreciate Colby for coming in while on the job here to speak with all of us, and Jim for that great description. You know, a lot of what we do at Department of Energy when we're talking about heat pumps is begin by highlighting that this is not just a piece of heating equipment, right? Because it's moving heat inside or outside the building. It's providing heating and cooling. So that was a great kind of crash course to get us up to speed there. If we can go to the next slide, I want to just give a bit of context for you all about the 3 major pieces of legislation that we see as critical to the president's Investing in America agenda and the underpinnings of what we're going to talk about today and the opportunities for heat pumps. The first one that was passed almost 2 years ago now, the Bipartisan Infrastructure Law, made the biggest long-term investment in our nation's infrastructure in nearly 100 years. A large portion of that money was DOE came to the Department of Energy for new funding for deployment of energy efficient and clean technologies. We really see this as the backbone, if you'll indulge my metaphor here, to create the infrastructure we need for the clean energy transition. Second, almost a year later, was the CHIPS and Science Act, really focused on investing in the innovative and cutting edge technologies we will need to have the component parts and all the equipment needed for this clean energy transition. We think about semiconductors and this other equipment as the brain of what we're trying to do as a nation here. And then finally, most of what we'll focus on today is incentives that were part of the Inflation Reduction Act passed in August of 2022. And this is the lungs. We are breathing life into the economy by providing a whole suite of incentives for a variety of clean energy technologies that can be taken advantage of by different entities and in communities across the country. So if we could go to the next slide. Zooming in now on the Inflation Reduction Act, a big focus of the administration is how we can save American families, American households, thousands of dollars in both their home and their transportation energy costs, saving at the pump, saving on their utility bills. A focus of many of these programs is for low and middle income consumers to really get at this challenge of energy burden, where so many of our neighbors have a high amount of their monthly budget goes to their utility bills. And that's a problem that we hope to solve here. Again, this is the largest climate and clean energy investment in American history. And in part, we are hopeful for the opportunity here because it provides 10 years of certainty. So the incentives that I'll describe today are in place for 10 years from the beginning of this calendar year, 2023, meaning that industry and investors have certainty and kind of what incentives will be available. We also will speak a bit about the focus and the increased incentives based on domestic job creation and strong incentives for projects that are done by paying prevailing wages to the workers that are doing them and allowing meeting apprenticeship requirements to make sure that the individuals working on these projects in your houses of worship are learning on the job and having a chance for advancement to go and be able to expand their work within the community. Finally, and I think this was relevant to part of what Jim was talking about and made this important point about heat pumps using electricity. Our analysis indicates that the impact of the Inflation Reduction Act would be that the U.S. will reduce greenhouse gases to roughly 40% below 2005 levels by 2030. A huge portion of that is going to be coming from the electric power sector because of the incentives for power plant operators and developers to shift to clean energy. There will be, we expect, much lower carbon intensity for every kilowatt hour of electricity that's produced in this country over the time period that's described here. And so, putting in a heat pump now or in the next 2 years, there will be a certain amount of emissions associated with the electricity that's used to power that in the near term, and that will steadily go down over the lifetime of the heat pump. So an important part of the puzzle here that isn't directly informing investments that you all are making, but will be a part of the emissions impact that installing a heat pump can have. If we could go to the next slide. The rest of what I'll share with you today is kind of divided into two main parts around two different incentives. The first one is the energy efficient commercial buildings tax deduction. Because these are so often used as short term, as you're talking with developers or tax advisors, you might hear them use the Internal Revenue Code section number, which is 179D. Just want to note here that the description of commercial buildings is basically meant to separate these buildings and the incentive from single family residential homes. So it doesn't have to be a place of commerce, but this is a deduction available for non-residential buildings, including houses of worship. The second one that we'll get to is the investment tax credit. This is section 48, and revisions and expansions that are in the Inflation Reduction Act, including the important provision for elective pay, which allows tax-exempt entities to be able to take advantage of the incentive in investing in their facilities. We can go to the next slide. Okay, boring stuff first. I work at the Department of Energy, and we do a ton of outreach and work on research and development and deployment of these clean technologies. But the Inflation Reduction Act provisions that have to do with the tax code and tax incentives for Americans is the purview of the Department of Treasury and the Internal Revenue Service. So we're excited to talk to you about what's in the law and the broad strokes of what's been released as guidance and made publicly available by Treasury and IRS, but what they write and what they put in their publications are the authoritative information here. So throughout this presentation and when you'll be able to see it in the recording, I'll try to point to different IRS publications and the sites where additional guidance will become available from irs.gov. And again, finally, please don't consider this itself tax guidance. And refer to the guidance and talk to appropriate tax professionals on how exactly your facility can take advantage of this. One other note I'll make is that the IRS will not only produce guidance that is final and complete with no future action. They also have provided public proposals or draft regulations or guidance for several of the incentives and allow the public to take comment on them. And we can say very similar to how we do at Department of Energy, all public comments on that draft or proposed guidance or regulation are carefully considered. So something for you all to consider as you are following along here and considering what proposals might be forthcoming. Next slide, please. Great. So a high level overview here of the 179D, again, the commercial building tax deduction for energy efficiency improvements. This is a incentive that's been around since 2005, but had significant expansion and revision in the Inflation Reduction Act. Important part to start with here, relevant for you all, is that the deduction itself is not available via elective pay or for the IRS to kind of provide directly to a nonprofit entity or a house of worship. But I think, as was mentioned earlier, tax-exempt entities can allocate the deduction to the designer of the building or the architect of the retrofit, and that could, subject to the agreement between the building owner and the entity doing the work, could lower the cost to the house of worship that is having a heat pump installed. You can see in the bottom right here, there are kind of four main systems that are eligible for this deduction, including HVAC, heating, ventilation, and air conditioning. And that's where air source heat pumps and ground source heat pumps both would fit in. I will just kind of underscore part of what Colby said earlier, that building envelope, especially for older buildings, can be another huge factor in how hard your HVAC system needs to work, and thus how much energy you're using. So in terms of both energy costs and emissions, considering a heat pump alongside insulation, air sealing, especially for older buildings, is a way to achieve more savings in terms of cost and emissions. The table here, I just want to highlight two pieces of this. One is that the deduction amount varies both by what percentage of either historical energy use or energy use compared to a standard kind of baseline model for your building is saved. So the deduction starts once you have designed a retrofit or a new building that saves 25% below the expected energy usage for a baseline building, and goes up every additional percent you save up to 50%. Of course, if you're able to save more than that, 55, 60, 70%, that's great. And you will just get the deduction value would just be capped at that, equivalent to 50% savings. Another piece here, these two columns on the right underscore the really critical 5 times the deduction kind of bonus that's achieved if the project and the retrofit meet the prevailing wage and apprenticeship requirements that I described earlier. So really high value in this deduction is placed on ensuring that workers are paid a prevailing wage and apprenticeship opportunities are made available to them. We go to the next slide. This is a summary of some of the things that have changed as a result of the Inflation Reduction Act compared to the historic deduction, but I hope that many of those things are clear and look familiar. Number 3 here is really a key piece of it, that tax-exempt entities are now able to allocate their deduction. And that was previously only available to state and locally owned, government-owned buildings. So that expansion, we really hope, will be a new opportunity for you all and for others across the country. And then finally, just want to highlight the graphic below here that traditionally the deduction was based on a standard for commercial building, a new build, which really means that the possible benefit for savings was often only cost effective to pursue if you were building a new building and just were building a little more efficient. Whereas trying to retrofit an old building and get it up above a newer standard would be very difficult. So the new pathway here, this alternative pathway on the right, measures savings compared to your previous energy usage in that building. And that we hope will give a great opportunity to older buildings with maybe not great insulation and older inefficient equipment, the chance to see significant savings and have an incentive for those. If we could go to the next slide. I'll leave these for folks to look at, but this is existing IRS information on the two pieces of this deduction that are currently available. If we go to the next slide, I'll try to move through this quickly because I want to be mindful of time here. But the other significant incentive and opportunity that we see in the Inflation Reduction Act for you all is the elective pay option. So for a number of the different clean energy tax credits, tax-exempt entities can get a payment from IRS, even though they're not paying taxes. That payment is equal to what they would have gotten as a credit if they owed taxes and were having those taxes reduced. Those can be combined with additional other grants and loans. And there is a process for eligible entities to go through a pre-filing registration. I'll have a little more detail on that in another slide. If we get to the next slide. Great. So this is a slide we've provided, across the country to various communities. The piece I want to highlight here for you all is that the investment tax credit, in particular, Section 48, has a 30%. I think I may have seen this in the Q&A briefly as well. This is a 30% credit for certain types of clean energy investments. That includes clean electricity on site, including solar, includes battery storage. It also includes energy efficient technologies, including geothermal heat pumps. So ground source heat pumps in particular are eligible for this credit and the elective pay option. Air source heat pumps are not, and they're best considered for 179D. Will you go to the next slide? Great. Again, just to highlight here, under the Inflation Reduction Act, the expansion of organizations that are able to take advantage of these credits through elective pay. And again, that in that first row and first sub-bullet there, you can see houses of worship and religious organizations specifically are considered eligible. Next slide. This is another one I look forward to having available to folks on the recording to review again. But there are these 5 distinct steps that can help an organization kind of understand, from identifying a project that may be eligible, knowing from the beginning what these steps will be and how to ensure that you're able to register, file, and get payment afterwards. I will make the important point here that the payment received happens after the project is completed. So there is some element of trying to figure out how to pay that upfront cost with the knowledge that you'll be able to get the elective pay to offset it once the project is complete. Next slide, please. I want to touch just very briefly on some additional bonuses to several of the tax credits, including the ITC. So I think particularly in a situation where a house of worship is interested in a geothermal heat pump and taking the elective pay option for the investment tax credit, keep in mind that, again, here, prevailing wage and apprenticeship requirements are a key part of the value and how much that credit is worth. And more information on that and each of these is available on irs.gov. If a project is located in what's called an energy community, and these are areas of focus with, for example, closed coal mines or coal-fired power plants, but communities that have been identified as particularly impacted by a transition away from fossil fuels. This is an additional increase in the value of that credit, including for elective pay options. And then again, here within low-income communities, there's an application required on that, and more information is available on the IRS website. And then finally, projects that do have components and equipment that meets a set of domestic content requirements. Again, this is to incentivize equipment and materials that are made here in the United States by American workers. That's another opportunity to increase the amount of the credit that can be eligible. Next slide. I think we're close to the end here. So once again, Inflation Reduction Act information on tax incentives is available. The definitive information is at irs.gov. We do also have a government-wide website, cleanenergy.gov, that includes, includes information on a number of different incentives, including the direct or the elective pay option that I just talked about. And I think that is it. Broadly speaking here, I mentioned cleanenergy.gov again, but for vehicles, a great website to understand the incentives are fueleconomy.gov. And then particularly now for households and families, we are working to get a lot of the critical incentives up on our energy.gov save website. So this is more consumer focused, but members of your congregations and yourselves may be interested in seeing that as well. So thank you again for your time and look forward to answering any questions I can.
Thank you, John, for that presentation. We're grateful for the time and wisdom and insight you shared with us. We'll now show a video before we turn to our fourth and final panelist. We'll be showing a video related to the church that Jim Fritz belongs to. We can have that video.
Good Shepherd Lutheran Church of Decorah, Iowa was founded by local residents in 1958. They purchased land that had formerly been a sheep pasture. Later in 1958, they broke ground on the original sanctuary, the building to the left, as well as the education wing in the center. By 1988, the congregation had outgrown its original sanctuary and built the existing facility on the right. The congregation began the journey to a carbon-neutral net zero future with a 2012 Energy Star certification. The entire facility was switched to LED lighting in 2015, and a power purchase agreement with the congregant placed the first solar array on an adjacent annex building. By 2018, the original 8 natural gas furnaces had begun to fail, and the congregation undertook a major renovation of the original education wing. This included installing 4 5-ton geothermal heat pumps to replace half of the gas furnaces. These heat pumps were supported by a large geothermal field in the backyard consisting of 15 horizontal bored loops. In 2022, Good Shepherd members Jim and Liz Fritz formed a company, Mission Green LLC, to help the congregation replace the 4 remaining rooftop furnaces on the sanctuary. Mission Green proposed to add additional solar, including a solar array on a pergola as well as a rooftop solar array on the education wing. The rooftop array included 52 bifacial panels generating 21 kilowatts of energy, while the pergola array featured 50 bifacial panels generating 27 kilowatts of energy. The original building was heated with fuel oil until the 1960s when natural gas became available. The old fuel oil barrel was removed during the Mission Green project. 3 5-ton air-to-air heat pumps were installed outside the sanctuary. Variable refrigerant flow lines run through the building to individual indoor units. Every room in the entire facility is zoned individually for heating and cooling. The congregation also committed to planting more trees in our green space. In the past 5 years, we've planted over 40 trees and bushes to lower our carbon footprint. Our church garden, tended by congregation members, supports our local food pantry. This dark brown grassy area will become a 4,500 square foot pollinator prairie using wildflowers native to the Iowa tall grass prairies. This eliminates a lot of useless mowing and lowers our carbon footprint. It will help support butterflies, bees, and other pollinators vital to our planet's ecosystem. Climate change is real, and we've experienced significant drought this summer. The back lawn still needs much reclamation following the construction project done by Mission Green. We hope our entire lawn looks this green next spring. The pergola is a post and beam construction by a local craftsman and utilizes Douglas fir timbers. The racking system for the pergola solar array is an innovative black anodized aluminum product that provides a watertight area below. The permeable paver courtyard, located just outside of our fellowship hall, sits atop a huge French drain to handle all the rooftop runoff that had been problematic in the past. It is made up of over 200 tons of crushed gravel. The stylized cross in the courtyard center is an homage to the original cross designed for the 1958 building. It fell into disrepair and was removed. Now it's back. The members of Good Shepherd have been solid supporters of this project. A congregational vote to approve the collaboration with Mission Green passed by an overwhelming 99-4 majority. We are all proud of our efforts to move the needle to mitigate climate change and end the use of fossil fuels. Our facilities are now 100% electric and carbon neutral. We are a net zero energy facility as we generate sufficient power for all of our needs on site with 56 kilowatts of solar and 110% net metering with Alliant Energy. We continue to strive to lessen our carbon footprint. Following a 6-year power purchase agreement and a lease with Mission Green, the congregation will own all of the new equipment. This will allow the money previously spent on energy costs to be used to further the church's mission. We hope this model will inspire others to join us in the quest to save the planet.
Well, thank you for that wonderful video. Jim, we will now turn to you to hear more about the endeavors of your church.
Thank you. I'd like to thank the United Church of Christ and IPL for hosting this webinar and inviting me to share our congregation's experience. Good Shepherd Lutheran Church is a small rural Iowa congregation. We had a total of 8 aging natural gas furnaces and had no basement nor attic to work with, as it's all built on a slab and has only one level. The ductwork in the original buildings was large clay tiles buried in the dirt below the slab and was uninsulated. This was extremely inefficient and needed to be abandoned. However, there wasn't sufficient space for traditional ductwork to be installed. The variable refrigerant flow method of delivery used with heat pumps allowed us to hide the small copper line sets in drop ceilings, in architecturally designed chases, and through small areas that would never accommodate traditional ductwork. We also chose heat pumps because of the incredible efficiencies compared with all other options. Our 2019 remodel of half our buildings utilized 4 LG 5-ton geothermal heat pumps. We installed a large horizontal bore geofield in our green space behind the church. The remaining 5 furnaces, 4 of which were large, unsightly rooftop furnaces that were nearly 35 years old and failing, were replaced with air-to-air heat pumps. We chose air-to-air for this final portion of our project because we no longer had room for an additional geofield nor an appropriate indoor utility room, and the technology had advanced significantly with the past few years to allow us to feel comfortable with their winter performance. We are very happy with the overall performance of our systems. Besides the obvious benefits of energy savings, the variable speed controls at each head unit provide a constant, even source of conditioned air versus the 2-stage natural gas furnaces that had a temperature swing of over 4 degrees. The units are quiet, and heat pumps require no setbacks, making installation in public spaces easier to maintain and manage. We knew that the geo heat pumps would provide adequate heating regardless of the outdoor temperature, and hoped the new air-to-air heat pumps would too. We provided a backup heat source for the sanctuary due to our historic organ, just in case. However, 1 week after the air-to-air heat pumps were installed, the temperatures dropped to -17 degrees 3 nights in a row. The heat pumps maintained the 67-degree set point throughout the entire time. My wife and I formed Mission Green to help our congregation respond proactively to the impending need for HVAC upgrades. 80% of all HVAC replacements occur due to emergency scenarios, usually in the dead of winter. We didn't want an emergency to require us to simply go back to business as usual. We wanted to help the congregation be a leader in mitigating climate change by facilitating the opportunity to become carbon neutral and net zero energy use. This required a significant monetary commitment, but in 2021, nonprofits were not able to enjoy the tax benefits for solar and heat pump installations. Mission Green designed the system, educated the congregation on the technology, installed the entire system, and lease the heat pumps and solar to the church for 6 years. After that time, the congregation will own the entire system. There were many financial advantages to becoming carbon neutral and net zero. First, the most obvious is the incredible efficiencies of heat pumps versus old natural gas furnaces installed in the 1980s. This allowed us to heat and air condition our entire facility at a much lower cost. Second, providing sufficient solar arrays to meet 100% of the total energy costs for the church has insulated them from future increases in energy costs. Third, Mission Green is selling solar electricity at a discount compared to the cost from the local electric utility. Finally, Mission Green can secure the tax benefits and pass along the savings to the congregation. When the 6-year power purchase agreement and heat pump lease are completed, the congregation will no longer have any energy costs, saving them up to $10,000 per year. These monies may now be directed towards the mission of the church. Mission Green allowed the congregation to undertake a financially significant undertaking without spreading the costs, while spreading the costs over time and doing so at a substantial discount. The moral reasoning behind the decision to make these changes was fairly obvious based on the current climate trajectories. We have all lived a lifetime of cheap energy in the US, and the congregation felt it was time to pay it forward. We believe that we should act in a way that has a positive impact on future generations yet to come. We knew that our dollars could be better spent on church missions rather than on fossil fuel energy, which is at the root of our environmental crisis. Finally, we believe that it is an obligation of Christians to better care for the planet that is God-given. In the end, our congregation was willing. The Good Shepherd Carbon Neutral Initiative passed by 99-4 congregational vote. The technology was there, and it was simply the right and smart thing to do.
Thank you so much, Jim, for that inspiring presentation. We are grateful to each of our panelists and have time now for some questions and answers. I'm going to direct the first question to Colby. Colby, can you kind of tell us what are some of the legitimate or perhaps not legitimate obstacles to switching to heat pumps? If a church has, some of the concerns I've heard are, my church has a radiator system we can't switch, or my church is located in a particular part of the country where it doesn't make sense weather-wise for us to switch, or the ground source heat pumps are too expensive. What is your take on what are real obstacles and what's not?
Yeah, can y'all hear me okay?
Yes.
Yeah, the first obstacle is really the upfront cost. I would say that's the biggest. Like if you're moving from a central, steam system, for example, which is the most inefficient form of heat out there, but it's just so costly to transition. But that's the biggest obstacle is the upfront cost. Moving to like a ground source or even a water source heat pump, obviously it's probably about $5,000 per ton, where it was maybe $3,500, just 5 years ago. Costs are increasing for a number of reasons, but it is still much more efficient unit, and that's the way we would encourage churches, because there is a payback, and many times within your denomination, or there is, and I know a lot of houses of worship don't want to go into debt, but you can get a loan that is almost like guaranteed. You can't get it unless it's guaranteed to pay for itself out of energy savings. But again, the biggest obstacle up front is just transitioning from, for example, a central system or a packaged gas, packaged rooftop unit, which might have gas heat, over to an air source heat pump, which is the cheapest of the heat pumps, versus a ground source or a water source from installation. So that's the biggest.
Thank you for that response. Tiffany, do you have our next question?
I do. So many questions. Y'all are very engaged folks and paying attention to this, trying to figure this issue out. Lots of questions for John specific to the tax incentives from IRA that are coming down, and a lot of rightful confusion about the difference between the incentives around ground source heat pumps and other heat pumps. And so John wanted to see if you could summarize try to summarize again for us, what are the incentives available for ground source heat pumps, and then what incentives are available for air source, and then could you specify the differences help us tease out the differences and the benefits between both?
Sure, thanks, Tiffany. And maybe I'll talk about each of the two incentives I discussed one by one, so in case that's useful. So the Section 48, the investment tax credit, that's 30% of costs. That is written as something that is available for investments made in specific technologies. So that includes solar on site, it includes battery storage, and it very specifically includes geothermal or ground source heat pumps. Air source heat pumps are not included in that. So when you think about the investment tax credit, think about the specific heat pump option there being the ground source heat pump. For the energy efficient commercial building deduction, Section 179D, that is based on the deduction amount is based on how much you can save on different systems in the building in terms of energy or costs, including your heating and cooling system. So using either an air source heat pump or a ground source heat pump, you can reduce your cost or reduce your total energy use, and thus be eligible for that 179D deduction. Is that helpful, or Tiffany, anything else as a follow-on that could be helpful to clarify?
I think that helps. I also seen another question in the chat coming in right now as far as the difference between ground source heat pump and geothermals. I know that we have a lot of questions, and we've been capturing all the questions in the Q&A, lots of good ones, and we will put those in a document and ask John to help answer those after this and share that with you to also get to the questions on this, particularly on this topic where there's lots of questions and it's confusing. So we'll get that to you eventually.
Jim, a question for you, and having gone through this process at your church, do you have tips? This is heat pumps can be a kind of this foreign technology that maybe a lot of people in our congregations haven't heard about. Do you have tips for how to communicate and bring a congregation along in this process to end up at, doing what you want to do in terms of moving to heat pumps and really having these ambitious goals that your church has?
Yes, education was a huge part of our project. The confusion about heat pumps, how can geo be 450% more efficient? I mean, those numbers just did not make sense to the congregation. And it wasn't until I finally kind of coalesced on the idea that everything that we have done to this point, natural gas, fuel oil, coal, all that non-renewable fossil fuels, they burn in order to make heat. Heat pumps don't do that. They move heat. And the process of moving heat is far more efficient than is burning for whatever fuel source you should choose to use. So I think that was probably the largest tripping stone, was just wrapping your head around how do these things work. And once we were able to make that clear to the congregation, you could see light bulbs go on in the room. And it became a much easier process through that educational portion. The solar was pretty obvious. We already had some folks just didn't know how we were going to accomplish it. And when I designed the pergola, that became part of several problems we had with water and all that kind of stuff. So you got to kind of wrap everybody's head into the whole process and try to make it something that is complete from beginning to end so that you become net zero.
Thanks. I appreciate that response. Tiffany, I think we might have time for one more question. What question would you like to lift up?
Sure. So one more question for Jim, a question about how did your church provide ventilation for air, ventilation air for health and indoor air quality?
Yes, with COVID, that's become an issue. And we had some MERV filters in our old furnaces, which was part of what was helping. But we put in a high performance LED air purification system that goes through several different processes besides ultraviolet, It also had some, it has a regular pleated filter and so on, but it's actually quite a bit more efficient than what the existing filters that we had. And it's in our sanctuary and all of our public spaces surrounding the sanctuary that included the new air-to-air heat pumps.
Right, thank you. We've got a question, maybe Colby, you can help us. There's a lot of questions and discussions in the chat and so forth about kind of explaining what, kind of using the word vertical. What's this word vertical and how does it relate to installing heat pumps? Can you explain that and what the options are for different heat pumps?
Yeah, I mean, the horizontal versus the vertical heat pumps is just kind of based on the flow and the design. Horizontal ground source heat pumps, which you might see more like in Indiana, you're just kind of digging a ditch that's more horizontal and you're getting your heat from a horizontal design. And for example, Texas, so where I'm based out of Austin, Texas, you have to go deep in order to get a transfer there. And so you're going to have to go deep to either a water source well or something to that degree. So horizontal, you might see more in ground source heat pumps, and in certain areas and geographies make a big difference. And definitely reach out to a contractor or an engineer if you're considering either or. If you're doing, typically it's one well per ton, and if you're doing a 20-ton system for a vertical system, you're going to have 20 different wells out there per ton. So it just really makes a difference based on what kind of design you're going to do, and et cetera.
All right. Well, you are giving nice, succinct answers, informative answers. Let's try to see if we can squeeze in one more question. Tiffany, you have one more question for us?
I do. There was a category, and I'm not sure who to direct this to, Colby. It might be you, but there was several questions around the category of the refrigerants role in heat pumps and the environmental impact there. Wondering if one of you could speak to that, specifically questions about the global warming potential of those refrigerants, the environmental impact. Is there a refrigerant that is is there one that is has the least impact?
I'll start off and then hand it off. But we're doing away with refrigerant R22, and we're doing more for environmental friendly, like R410 and others like that help in that aspect. And I think there's even more environmental friendly refrigerant they're using for the newer technologies. But R410A, from an environmental standpoint, is much less of an impact than R22, which we're obviously getting rid of.
Great. Thank you. This has been a very informative webinar, certainly a lot to dive into and a lot to process and understand. We're grateful for the time that each of you have given to us to do this. And I think, this is certainly a topic that I think, will for many of us, we'll want to do further research and learning. And so we will put together and compile a list of the different links that have been shared and some of the further resources that our panelists have available. We will compile that and put that in our kind of post-webinar email so that everyone has that at their fingertips and continue this really important learning process so that in the end, we can do our best in our faith communities to care for creation and to care for this world by doing what we can for energy efficiency and to reduce our energy use. And certainly heat pumps are holy. And so thank you again to all of our guests for joining us today. Tiffany, any final words that you'd like to share with us?
No, thank you, Brooks, and to all the speakers and to all of you joining who are doing this important work that is complicated and slow going. Thank you for doing this.